Okay, so we're going to talk about testing, everyone's favorite topic, hot off some like weird emulator talks. We're going to talk about the basic stuff and nothing about Hoovers, unfortunately. So to anyone that hasn't met me, and I appreciate I am somewhat conspicuous, I'm David, I'm a software consultant. I wrote a few kids' books and I've built some massive web scale systems. Hopefully you've used something I've made, even if you don't realize it. But what I really do is I perpetually play with any and all technology I can get my hands on. And I've spent close to the past 20 years writing all sorts of tests and trying to do TDD in just about every language and stack that I've had the pleasure of working in. So are we ready to see how deep this iceberg really goes? If you pay close attention, there's some great controversial stuff in here. Now, a good portion of my own journey with software testing involved mostly good fortune and meeting the right people at the right time. I was originally a self-taught developer, and the truth is, my confession is for the first 10 years of my programming life, I didn't write a single test. Never heard of it, and everything seemed just fine. Honestly, everything seemed just fine. And my code kind of worked, and I didn't know what I didn't know, and I was happy. And I made it through an entire early 2000s computer science degree with nothing but the most casual reference to unit tests being made. Trust those degrees, folks. There were entire modules on the software testing life cycle, but not a single instance of here's a unit test. It was all very 1990s. And I was fortunate because in my very first job out of university, I was lucky enough to have a mentor that introduced me to the then relatively nascent concept of unit testing. And I didn't really get it straight away at all. But working with this mentor put me on this path of discovery that really hasn't stopped since. And so if he ever sees this, thank you, Andy Longshaw. You really you helped me when I was barely more mature than a precocious teenager. So while this talk on the surface is kind of about how to write tests that survive and a little bit about JavaScript, I suppose it's also a little bit about my own personal experience, because narcissist, I don't know, and how it changed the path of my entire career. So it's going to be one of those sessions where we start somewhere obvious and end up somewhere you might not expect, somewhere down the bottom. So we're going to start by covering some of the very, 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 very basics. And from time to time, I get asked the question why I'm so enthusiastic about automated testing, because it isn't really the sexy end of software for most people. It's the boring stuff, it's the tedious work. But for me, testing is beautiful. Like, testing is the thing we have that is fundamentally of software that wasn't borrowed or mimicked from another discipline. It's the thing we invented, it's our process, it's the thing that proves our software works. So whenever I'm faced with folks asking me, do I need to test X, Y, or Z? Or which part of the software should we skip testing? Like, what's the bits we don't need to test? My answer is the same every single time. Skip testing the bits of your software that you're happy failing in production. Because it will, right? It's inevitable. And, I'm not going to promise you that great coded tests will stop your software failing ever. But if you get your tests right, triangulating and fixing the software when it does do those things and does fail will be easier than ever. So let's talk about, again, the very foundational basics for a moment. And I'm probably preaching to the choir a little bit here because you've probably all heard of unit testing before. But first, a definition. So in computer programming, unit testing is a software testing method by which individual units of source code sets one or more computer program modules together with associated control data, usage procedures, and operating procedures are tested to determine whether they are fit for use. Thanks, Wikipedia. Who writes all that stuff, really? We're going to start by talking about, the humble garden variety unit test and what it is and what it isn't. So unit tests test a piece of code where unit means the unit of isolation. Now, that's the thing that's being tested, right? So unit tests use, they test functions, they test single functions, single classes. They're written with the help of a testing framework, and your test code is executed using a test runner, the thing that discovers and executes your tests. And unit tests contain one or more assertions, lines of code that verify the output of your function, class, or program, like very, very foundational knowledge. And As with most things in the whole of the JavaScript ecosystem, it doesn't take long to talk about a concept before people start arguing what we're going to use, what we're going to install from NPM, all that kind of stuff. The framework wars were bloody and there were only casualties on the way. So all the examples here are just going to be written in Jest because it's a combined test runner, framework, and assertion tool. It isn't the only tool available to write tests in JavaScript, but arguably it's, the standards were kind of set with libraries like Mocha and Jasmine in the early 2010s. And there are other libraries that enable different categories of testing. Things are quite popular, like Storybook, in the component and UI testing space. And newer tools like Vitest, kind of a spin-off from Vite, are up and coming at the moment. But, as with most things in software, brand recognition, sadly, and support tends to win. And, Jest is authored and supported by Meta, who knows? And Broadly is the most well-supported across the tool chain and the ecosystem. So it's probably the test framework that you're going to see the most. So I want to describe Jest and XUnit frameworks in general. So XUnit, if you didn't know, whilst it is the name of a framework in C#, it's also the name for the loose family of frameworks that all implement roughly the same pattern of test fixtures and test cases, regardless of the language of choice you're working in. So, the dominant testing framework tends to be XUnit styled. So in JavaScript, there's things like Jest, NUnit and XUnit in C#, JUnit in Java, etc. And actually, some trivia, the very first XUnit framework was SUnit in Smalltalk. So that's kind of where this pattern comes from. And so Jest, as stated, is maintained and supported by Facebook and used to test React, runs under Node, and contains all the stuff you need to get started. And once we have a test framework, we need our assertions, and assertions are used to verify the output of your functions. Now, most assertion libraries are just syntactic sugar over the top of some conditional checks and throwing exceptions. You can write your own assertion library in a couple of hours. It's not too difficult. And you can bring your own, but the truth is, with the testing landscape, most tools in 2022 are just fine. Like, there's a nice thing that we've got to this place of maturity that everything is kind of just fine, and you're not going to end up with sucky tools here. They all have individual wrinkles, but they all work. So people seem to think that the state of testing in the wild looks like this. You see this diagram in like 1,000 books or 1,000 web pages. You've probably not seen like this one, though, because unit tests are really just one of an increasingly broad category of tests. We have unit tests, integration tests, acceptance tests, end-to-end tests, smoke tests, consumer-driven contracts, toxicity tests. That's one that most people haven't heard of. UI automation tests, mutation tests. And what about BDD? How about Gherkin? Full stack tests? Right, but different kinds of tests are designed to help you at different times during different phases of your development life cycle. So it's kind of important to know what you're meant to be doing. So, if we look at something at build time, we have problems like code breaks. We have basic integration between components and like other nasty code junk, says a ruder word in my slide notes. The solutions here, we have unit tests and we have coverage, though coverage isn't correctness. We have integration, so cross-unit, cross-component tests. And the commonalities of all these categories of tests is that all of your dependencies can be mocked and stubbed, and it's all in process. So there's a category of tests that's all in process and at build time. Now, at deploy time, we have different categories of problems. So, they're often environmental, they're often consistency-based, related to downstream systems, they're often slower to diagnose and debug. So, the solutions to that is you end up with different categories of tests, like end-to-end acceptance testing without mocks, smoke tests that can run against any environment that are safe and give you a heads up on failure, right? So you reach for different tools. And then finally, at kind of a systems integration time, we have things like continuous tests running against third-party systems, consumer-driven contracts to check that the APIs you call haven't changed their shape, toxicity tests where you write repeated tests that enforce things like your standards and check that quality gates are being met across your software. And the commonality between all of this stuff is it all helps you fail faster. That's the point. So while that's a wonderful and diverse list of tests that helps you at various points, we need to be careful to crawl before we run. And, that's enough theory. Let's kind of get practical. And, I remember I was speaking to a guy called James Gregory years ago, and he said something to me that always stuck with me, which is, I've used all these different kinds of tests, and the only thing I reliably care about is tests that don't break when I don't want them to. And I thought that was actually quite revealingly insightful. So it's probably worth highlighting that while I'd love to be brave and just do this live in front of you here, I do not have the nerve to trust both NPM and conference Wi-Fi at the same time. I feel like that's two gambles that you shouldn't take at once. So many people will interact with code bases from some point after they were first created, right? And because of that, it's entirely possible that when you're trying to test in JavaScript especially, actually you're approaching a project that's already got like a whole cavalcade of tooling and gumph from NPM strewn all over it, and everything is set up and you kind of don't really know how this hangs together. So it's no secret that the JavaScript ecosystem is wide and complex, and it's easy to think that you need a whole bunch of tooling like Webpack and compilers and God knows what to get started, but really, actually, you don't. And what we're going to do here is we're going to new up a new node project, and we're going to install 3 packages, and I'm going to explain what those packages do and how you can turn testing on. So like with everything, there are a few wrinkles you need to navigate in the form of a tiny bit of configuration, but I'll try and explain not just what the configuration is, but why you need it. Now, presuming we already have a modern version of Node installed, we're going to just node init a new application here and install 3 packages. Now, those packages are Jest, Jest CLI, and the wonderfully catchily named Babel preset env. Cool. So Jest is obviously the test framework we've been talking about, and we're going to include that in our code base. In other ecosystems, you'll see JUnit, NUnit, whatever. Jest CLI is the test runner that can be called from the command line, and it executes your test code. Now, Babel preset env is a plugin for Babel, which is implicitly used by Jest, which what it does is it compiles your test for whatever version of Node you have installed automatically when Jest runs. So you don't need to worry about Webpack and transpilation and targeting whatever version of ES current, whatever version of Node you support, it'll take care of it. So we need to use the preset env package to use modern JavaScript modules in our code, along with other language features. So once we've done this npm init, we need to tweak a few things in package.json. So we want to first enable ES6 modules. So we're going to flip the type of our project to be a module. Now, everyone should be doing this today. And like set Webpack on fire. Really, set Webpack on fire. It's a hellscape that lets you shoot yourself in the foot with 2 guns. Please, I beg of you. So everyone should use these modules. They work in your browser natively now as well, so there's really no excuse. So by setting the type property in your package.json, the node runtime allows you to use the import and export module syntax. There are other ways you can achieve the same effect. So you can like rename all your JavaScript files to .mjs, which is just annoying and nobody wants to do that. So flagging as a module is the cleanest way. Once we've done that, we're going to update our scripts configuration to call Jest. Now, this just means that when we type npm run test on our command line, it will actually do something. Now, you can install Jest as a global tool and make sure it's in your path and all sorts of stuff, but I don't know why you would do that. Like, I don't know why it supports that at all. And then finally, we're going to add some Babel configuration, the most arcane-looking bit of all of this. So this configuration can appear arcane, but it's better than trying to learn how to use Webpack. And if you get this right, you should never have to look at it ever again. All we're saying here is configure Jest's implicitly called version of Babel to apply the preset for our current version of Node, and a lot of brackets. So it's probably worth noting if you're using TypeScript, you'll probably end up using something like TS Jest instead, and you won't need to do this because it already has compilers that make sure the packaging and module system works, so you don't need to worry about it so much. Now, let's take a look at a very, very basic Jest test. Now, I don't know if anyone's seen this before. First, note that we've called it index.spec.js. So Jest by default looks for things called .spec. Now, I know certainly, if you're from like a .NET background, that's a weird naming convention because spec has other connotations in their ecosystem. But, you can configure it to use like star.test.js if you want to, but that involves extra config that you don't really need. So we're going to go through a few things. We have a file that exports a single function here on the right. And now on the left, there's a test file illustrating Jest standard testing conventions. So there's an import for our code, a describe block with an embedded closure for the tests, and an it block with the test inside of it. Now, the it block is our test method. The name of the test lives in the brackets, And our names follow a very, very simple naming convention of like what happened, under what condition, and your expected output. Now, you can be clever and craft sentences in Jest because it renders the output funnily, but I'd rather have tests that I can read when I'm glancing at the code than glancing at the test output. Now, it's worth noting, again, that we're using the native import and export keywords of the language here. That's what we get from ES6 modules. It works pretty well, especially if you've perhaps been trapped in the hell of compatibility with common JS and AMD modules in the past. Like, this is the module system you expected your language to have. Now, if you've not done much JavaScript in a long time, I'm happy to report that classes work now too. And you can use them in exactly the same way that you would in other languages. And you might hear 1,000 people blog about how JavaScript doesn't understand classes and it's not the prototype chain. And bores, they're wrong. You should absolutely use the syntactic sugar put in the language to help you organize code in whatever way makes it more legible to you, always. They work fine. Use them as appropriate. And it works. No, animations, cool. Didn't know that was there. You too can now do TDD in JavaScript without any weird tooling. That's it. That's like the whole bit at the start. Now, this is about as close to using an XUnit framework as in any roughly comparable language you get. And if you like, you can configure an npm watch task to run your tests repeatedly when you save your files. But we can probably do better than that. Iceberg. Now, if that's unit testing, what's TDD and why is it different? Now, obviously, test-driven development is a software development process that relies on the repetition of a short development cycle. Now, requirements are turned into specific test cases, and then the software is improved to pass the new tests only. Now, this is opposed to like classical software development that allows software to be added that's not proven to meet requirements, right? And this is the TDD by example. This is the Bible. It was published in 2003 by this lovely man. This is Kent Beck. Kent Beck is our like one good old white guy. Right, like Kent Beck, in his own words, is not a great programmer. He's just a good programmer with good habits, and I always thought that was a really, really great sentiment. So TDD was part of the broader XP, the extreme programming movement of the late 90s, and Test First was promoted as a concept from XP since around 1999 or so. And Kent Beck always just says he rediscovered this thing. Now, in Beck's own words, the original description of TDD was in an ancient book about programming. It said you take the input tape, manually type in the output tape you expect, then program until the actual output tape matches the expected output. After I'd written the first XUnit framework in Smalltalk, I remembered reading this and tried it out, and that was the origin of TDD for me. So when describing TDD to older programmers, I often hear, of course, how else could you program? Therefore, I refer to my role as rediscovering TDD. Everyone remembers the dress, right? Gold and white. While unit tests are all about testing the units of code, they're not a workflow, right? They're not a process or methodology. They're just a programming tool. And unit tests verifying the correctness of your implementation is their entire job. That's it. Right? So test-driven development, conversely, is all about building out new pieces of functionality, of behavior, and verifying that instead. Now, TDD is a working practice, an approach with the tests you produce existing almost as a side effect. Now, it's why advocates of the process describe it as test-driven design sometimes, where really what you're doing is discovering the structure of your program through experimentation and testing. So advocates for this approach, including myself, believe this reduces waste and over-design, because we've all seen some stuff. Now, the TDD method is described as red-green refactor. And in the red phase, your challenge is to get a test failing as quickly as possible. Now, that red can be as simple as non-valid code or non-compiling code in compiled languages. And this red test expresses an outcome, a thing that you wish your software did. Now, then the challenge is to do the simplest thing that can possibly work to make the test go green. And so help me God, so many people struggle with the concept of the simplest thing that can possibly work. And, it might be pasting in some dubious code from Stack Overflow. That's cool. I see you. I'm okay with that. It might be hacking some ugly code that just gets the job done, or even hard coding a value. That's my favorite. Now, the people that get TDD wrong stop here, right? They get green and they stop and they ship it. The final part is the iterative loop. It's refactoring the code to make it good enough. It's the most important part of TDD and of the workflow because it's where you shift things around, literally changing the factoring, but not the behavior, supported by your hopefully still green test. Now, again, in TDD by example, what it says is that the different phases can have different purposes. They call for different styles of solution, different aesthetic viewpoints. And the first 3 phases need to go by quickly so we get to a known state where with the new functionality. We can commit any number of sins to get there. We all love sins. Because speed trumps design just for that brief moment. So to the developer of software, the argument for any kind of code-based testing is very, very simple. Is it faster than running the program? And it always is. So after that brief kind of history lesson and my subtle adoring of Mr. Beck, we're going to get back to the practical stuff. So the thing about those TDD workflows, they mean you end up running your code like a lot, like so frequently you bash out the keys for the running test runners. And in JavaScript, the standard solution for this is to use a file watcher and run your tests every time the files get saved. But there is a better way. Continuous test runners execute any tests affected by changes you make to your software on each and every key press, instantly inside of your editor. Now, the first time I used a continuous test runner, I didn't really understand what all the fuss was about, and this was Ncrunch in .NET. And I was pairing with someone for 2 days, and at the end of the first day, I went and bought my own copy because it literally changed my programming workflow so significantly I've never looked back. So Wallaby is a continuous test runner for JavaScript, and for the rest of this session, when you see screenshots from VS Code, we'll be using Wallaby. Now, it's amazing. It's by far and away the best tool in all of JavaScript, and perhaps the best continuous test runner I've ever used. It's not free. It costs you £99 a year, and I think £199 for organizations. It's worth every single penny. You will make that money back instantly. And I'm not going to resist the urge to climb on my soapbox and labor the point that as professionals, we should be buying software from other professionals or we all go hungry. So please, please support tiny companies with good tools. They're not essential to do TDD, continuous test runners, but honestly, it'll make your orders of magnitude faster. And they really don't pay me for this. So running with Wallaby, you no longer have to use any NPM watchers. There's a whole host of other features. You can do things like log in line and watch the results output inside your IDE. You can get instant feedback on code changes, and you can do wild stuff like debugging backwards through your code. So you can step backwards and see the entire stack. It's really wild and very, very good. Wallaby's amazing. They should probably pay me for this promo. So you can see here, if I change my invoke function to return false, Wallaby provides this in IDE feedback, so you get the kind of stuff you would see on the console right in line. Buy it or nag your boss. Both. Okay, so now we understand what a test is, we understand what Jest is, we understand what a test runner is and assertions are. I want to talk a little bit about something I really love, and I've been thinking about this for about 15 years, and it's about intentionality in code. So I suppose what we have to do is we have to address the elephant in the room. Ready to be mad? Everyone ready to be mad? Oh, this guy. Burn your copies of clean code. It's aged very poorly, and it means we do not have to fuck with he who shall not be named. It's not classy to twist the knife, but suffice to say, everything in Beck's work dwarfs everyone's least favorite family member. Clean Code is an extremely dogmatic book, and its presence in the industry has reduced discussions about quality to discussions about naming variables. It's muted conversations about architectural style in the same way dogmatic adherence to the solid principles has stopped intelligent conversations about architecture. Its shadow is long, and it's one of thoughtless dogma followed blindly. Please don't. Heresy. I hear you cry. You can't say that about clean code. I love writing clean code. So, there was a point in my career where I too thought the rules around basic hygiene were enough. But over the last 5 or so years, I've come to value intentionality in code over any sense of syntactic cleanliness. So what does that mean? It means that every character matters. Every single thing you do. Now, the most valuable thing I learned about software was to reason about it like a body of literature. It has text, it has subtext, it has authorial intent. Software is the means of communicating intent between developer and developer. Sometimes we get it more right than others. But in writing our code, and especially in writing our tests, I want you to approach the work as if every character matters. Be intentional. The white space matters. The rhythm of your code matters. Naming does matter. Form matters. Function matters. And when we're talking about writing tests that survive, that are legible, that are useful, tests written with thoughtfulness and intentionality for the reader are what matters. So let's start with a few guiding principles, iceberg, and then we can get really, really deep into specific examples. Now, good tests test the what, not the how. They're not implementation specific. They don't require huge amounts of state to understand. They test single things, be they concepts, outputs, or functions, and they need to be just as good, just as intentional as the code that you are testing. Now, I'm going to go through some examples of how we can make some tests look good from both bad and good perspectives. So this is like the first tier of knowing things about tests. Now, the AAA pattern, I like it because it sounds like screaming. So tests should, as a general rule, follow this arrange, act, assert pattern. It's like stanzas in a poem. They should make it easier to understand the intent of the code because it splits up the preparation of test data, the actual test, and then the assertions. Now, you'll hopefully see this pattern everywhere if you've ever written any tests before, even if you didn't know it had a name. Also, while attempting to call out what you're doing, please use white space intentionally too. So please don't add // arrange // act // like we know what it means. Please don't. It's an organizational pattern. It doesn't have to make your code ugly. So where possible, we should use relatively standard names for things, like system under test, and the names of the tests themselves. As a general rule, people have trended towards using SUT, standing for system under test, to describe the thing that you're testing where possible. This is the most relevant in situations where you're testing classes or entire composed applications, or modules where you have dependencies flying around. Now, it makes it more obvious when you're interacting with your test code and when you're interacting with the unit of isolation. We're also using a standard naming pattern for tests that I mentioned before, kind of formatting aside. The test name should always tell you what you're invoking under what condition and what expectation you have of the thing. The number of code bases I've seen with test 1, test 2, test 3, like people think it's not out there, but it's everywhere. So here's an example file. So I horrifyingly went shopping for big JavaScript projects with tests, and it took me a while to find them. So I borrowed this spec file from an MIT-licensed major open source project on the internet. We're not going to name and shame. It's from some test code regarding the handling of site configuration. And it's certainly not the worst test file I've ever seen. But what we're going to do, we're going to go through a number of techniques that would improve its quality and maintainability and readability. And, everything matters, even things this small. So we're going to revisit this a few times. But that's what it started off like. And yeah, I'm not really sure what it does. So firstly, use white space wisely. In this example, one of the handful of problems is that a total lack of white space in the test file here slows down your comprehension. Now, white space exists in code for the same reason it exists in written language, to help direct the reader, to give you a pause, to let you think. Use it. The file on the left here has absolutely no significant white space, indicating either the different tests or that there's clearly different phases in these individual test functions, but they're totally not delineated. So introducing some new lines, as shown to the right, makes the tests easier to read because you know when you're meant to pause. So people that do this fall into this trap of making their tests this terse, and they do it because they mistake uniformity, the way something looks neat and similar, they mistake that for expressiveness, where we use form and shape intentionally to convey meaning. It's far better for distinct parts of your test files and functions, or any code at all, to look different when they do different things, because the visual variation leads the eye, it encourages reading, instead of the skimming that large bodies of identical looking text leads to, right? And I know it's weird kind of approaching this from a pure aesthetic viewpoint, but it's design. Now, no magic numbers, and like most test code bases I ever see suffer this problem. So magic numbers in test code are even more evil than magic numbers in real code, because they make me believe that the value of that thing is important, right? So if I see a -2 in a test, I think it means something. I think there's something special in that code that's going to react to that, right? You should always give test input data names to establish context, right? Because here, the -1 is a magic number and needs a name. Now, I need the author of the test to tell me why that it is that number. I need to know if I should worry about it or not. Even though I'm describing this as magic numbers, it applies to all test data. We've got to make sure there are no magic strings that appear to have meaning either, or any data structures that look real. So one of the common tricks to make your test data stand out is to literally call it out in the data. If you're passing a string to a function that you don't care about, why not give it a value of some valid data or unimportant data to make it really obviously garbage so that the reader understands that it isn't important? And in this specific example, we could have also relied on the test name to provide the invalid weak context that we see here. It's not quite as legible as the -1 still feels a little bit magic, but in a test so small, context is key, and it's a tolerable compromise. It probably doesn't affect the experience of the reader if we make it smaller here. And, again, remember, golden rule, always optimizing for the reader. Now, we should also avoid unnecessary data. Like a relevant test code that doesn't affect the execution of the software should not be in your tests ever. So here, the unnecessary test data, all of those headers, make you think that they're important. They make you think that's what a valid request looks like. But if you actually look at the code, it's not true, right? It's impossible to understand what's going on in this test because you're just sucker punched by a wall of text and noise and chaos. That's the name of my grindcore album. You need to make sure that when you're specifying test data, you include only the data that impacts the behavior of the test themselves, because anything else is a distraction and fools the reader into thinking that it's required. So remove the noise to increase the legibility. Now you can see the exact condition that triggers the behavior you're testing for, because our actual implementation only actually checks the request method property, and we can slim down the test code to only specify the data that triggers our check. In this case, it has to be a get or it throws. Now, as much as possible, we should avoid repetition in test data too, because the visual noise causes the reader to start skimming and not recognize the difference between those tests. So here we have code that requires a whole lot of test data to execute, but because we're testing two different scenarios, we have two different tests. We need to extract the commonalities between those two tests. Now, by extracting out the request construction, we can more clearly see the intent of our code, rather than be blindsided by the noise of test data everywhere. Our valid request with function takes two arguments that will create test data in the correct form for both of those tests. And yes, before anybody yells, we are technically drying out our test code base here, I know. But you should always strive to remove any statements that are inconsequential from the understanding of the test to something else elsewhere. Like tests should be tiny. Now, this looks like the same slide, but it isn't. It's important to keep your test up to date with the latest language changes available to you too. This might seem as though it's the same, but we can use more modern JavaScript language features to improve visual noise. So here, what we're doing that's different is we're destructuring the result of the HTTP GET function and extracting the body and using includes instead of like index of and the relatively arcane -1 there to check if our return string contains a data value or the other data value. Now, these subtle improvements to language may seem invisible at a skim read, but when you're the developer trying to read the work and understand why something is broken, tight, legible, production-grade test code will make your life a tremendous amount easier. You should continually revisit and update your test code as your software grows, and as languages, tooling, and standards change around you too. And you've got to remember, like all software, it is never done. You've never written the tests and they're finished. Things change. Now, if you find yourself extracting similar categories of data to helper functions too often, your code base might be in need of some kind of test data building pattern. So this is another common approach. So test data builder functions or classes for well-known categories of test data remove visual noise not only from the test, but to a completely different location altogether to make it easier to comprehend. Now, they do this, and you can use your test data builders to construct known categories of test data that can then be shared amongst different tests. Think of it as like DDD, but for tests, I guess, is probably the easiest way to think about it. You make your test cases a first-class concept in your application. So again, it makes it much easier for future developers to understand what you were thinking. And, it's trivial to accidentally add dependencies on out-of-process systems that you don't control. So it's important that we also isolate our tests from data storage or anything you request over the network. Now, if you're caught online or get rate limited here, your tests become unreliable and flicker. Now, we're inevitably going to talk about, mocking here, and mocking is dangerous. So you can use Jest's built-in mock functions to mock the behavior of other modules or files in your applications. But if you go and Google Jest's documentation for this stuff, it's really bad, really, really exceptionally poor. But this is the easiest way to do it. Now, Jest has this whole convention where you can add files with pre-canned mocks in them, but I don't know why you would ever use any of that stuff, because all you're doing is you're taking logic that belongs in your test and just putting it in a random directory somewhere else. It doesn't make any sense. It's a really silly approach. So it's important to highlight that in JavaScript, you have to make sure that you call Jest mock before you import anything else from the module you want to mock. Otherwise, the package loader will grab your actual code rather than the mock. So at the very top of the file, we're mocking out node fetch here. This prevents any imports accidentally loading our real dependency. And then you should be careful when introducing mocks into your test code, because mocking, again, is the act of swapping out one dependency for another. But it's very common that tests that use extensive amounts of mocking become brittle. Now, as any change in the way one component uses another often induces rippling changes throughout the code base, all of those tests with deep mocks around expectations will all break. So use mocks, but try and use them to only isolate yourself from external systems that you can't control, like web APIs or databases or sometimes the file system. If you're mocking out your own code often, what you're really doing is you're building software that's tying you into a specific implementation. So you should assert on only one concept or capability per test. Now, this is often misinterpreted as meaning only one assert statement, right? Like a classic fumble of words, but we can be far gentler here. In this example, we're testing that a library can reset its configuration. Now, it clearly contains two kinds of configuration, some kind of global site config and some regular config object. Now, the ability to reset both of these values are individual features of the code and should be split into two separate tests, even though the resulting output looks worse. It looks like weird copy and pasted stuff, but we'll come back and we'll tidy that up a bit later. Now, what I want to do is I want to revisit this example file and see if we can apply some of the techniques here. Now, before we did anything to the file, it looked like this. This is the whole file split left to right. Now, yeah, I'm not really sure what properly means. I don't know what a directive is. And God knows what all those different config files are. Exactly the same set of assertions could be written like that by following those rules. Some gentle rework, we reduce it down to this. So what did we actually do here? Now, we reduced the cognitive load so that every single thing you see in those test lines matters. We introduced white space to help the reader split out some concepts into their own tests. But most importantly, the one most significant change is that we stopped testing the basics again and again and again in every test. All of those tests here just repeat the same assertions. It's stupid. It doesn't make any sense. They're relying on what we're doing now is, relying on distinct tests to cover scenarios, because that copy-paste in the previous test was obscuring the actual intent of the individual tests. Now, I know it doesn't seem like much, but I hope you'll agree that the difference here to legibility is pretty huge, actually. And, of the tests, especially with some rework naming, it's really significant because, again, intentionality. Every line of code matters there, and I cannot say the same thing about all that. So, okay, next level down. So far we've spoken about the small minutiae of increasing legibility of our tests, but I want to talk to you about my two big rules. These are the most important things in all the testing. You test what, not how, and you test the capabilities of code, not the data in your tests. Now, I believe that these two things together are the difference between poorly factored tests and tests that last. Let's look at what that really means. So testing the exact implementation of a dependency is one of the most common pitfalls in testing. You should be testing the outcomes of your system under test, not how they reach their conclusion. Now, tests that test precise implementations are brittle to change, and you'll have to rework them if you ever change the code. So tests that, tests that test the outcomes of a piece of code are resilient to change and can have implementation swapped over time while the tests still remain valid. And that's like one of these big golden rules. It's a gold standard to check if you've got a good test. Can I replace my entire implementation and have my test still work? Now, in this example, we're asserting explicitly that our weather API is called by URL. And that's a leaky abstraction because there's an API key in there. Like, this is literally testing how we are reaching our conclusion, not the outcomes of the test. And, as soon as our API key changes, the tests blow up. And we didn't break our code still works. It's leaking knowledge also of the document response formats of the underlying system. Now, if we change our weather API, this test will still pass. Here, when we're testing the what, perhaps with a single change to our weather API returns temp helper function. So it's important to note that we're still exposing some elements of the implementation here. Our test code still needs to know what the format of the response body from that weather API is, but it's the smallest possible compromise we can make to make this a good test. It's okay if you have to change one of your testing abstractions. If your implementation significantly changes, it's okay, it's not the end of the world, but you want to make sure the blast radius of those changes are very, very small. So by building these kind of helper methods to construct this stuff, we keep those changes centralized. Now you could go further, and you could extract this logic into its own specific adapter class, but for a scenario this narrow, what you'd end up doing is writing tests around the adapter, then tests that checking that you were calling the adapter, and then a simple refactor would mean you'd have to change two things that are really asserting the same concept. Doesn't really make any sense, and also don't hard-code API keys. Stupid. Okay, so the best example of testing capabilities over data is the diamond catter. The funny thing is I use this as an interview question, so I hope no one's watching. The diamond catter, if you've never heard of it, is probably my favorite TDD exercise. The idea is simple. Given a character from the alphabet, print a diamond of its output with the character being on the middle line of the diamond. You can see the desired output in the slide here, but the idea is that you incrementally build up each of the features of the code that generates the diamond bit by bit. It's a TDD catter. And it's especially tricky as a TDD catter because, the alphabet's really well known. People know the data, so they fall into a trap. Now, it isn't too difficult. There are probably 20 ways of solving this that I've seen that I can trivially remember. Here's a solution I'm using for this catter. Don't worry too much about how it works. It's the testing style that we really care about. But in this case, and in case you're curious, the solution we're using is to loop all the way up the alphabet to generate the top half of the diamond. We're doing a second loop to pad out the bit in the middle, and then we're flipping and mirroring it. Right? Now, this is the example of the kind of tests I often see for the diamond catter. These ocean boiling tests that, they're not just testing the data, but they're also very hard to incrementally TDD because they require this entire fully working thing to pass. If you write tests like this, it stops you from decomposing the problem that you're working on into these smaller chunks. And because it'll take almost the entire time you're programming to get a green test, you kind of break that red-green refactor workflow, right? It's kind of red, finish it, right? It's a perfect example of how people often start trying to think about the diamond catter, and it's why it's my favorite testing example, because it's basically this, isn't it? Right? Don't write tests like that. Tests like this make the draw the rest of the owl thing real in your implementation. We don't want to do this. So a better solution focuses on the capabilities of your code and not the data. Now, you'll notice we go out of our way here to turn the data into categories or classes of data. So you see we have an edge case, we have A, and then another category, which is all of the letters that aren't A. But you could pretty much change the test data in these tests and they would all still work, right? So we're building up a test by inspecting the qualities of the code that constructs a diamond for the output, and we're testing what the code does rather than just that it does it at all. So this means that if any of our specific capabilities get broken, like the padding or making sure the diamond's the right length, we'll know which bit of the code failed, not just it's broken. So learning to test what and not the how is, in my opinion, the most important lesson you will ever learn in testing. Like, this is what makes good tests. Now, there's actually an argument here that given the problem posed by the diamond catter, you could just hard code 26 diamonds and it'd be fine. And you know what? I would accept that as a solution because it's a constrained problem space, but like fugly. Okay, so final tier. We've arrived at this weird inflection point where we have so many different types of tests that actually it makes things more confusing, not less. It's funny that. So people get stuck in these like cyclical conversations about what type of test to use in what context. And because there are just so many definitions going around and just so many subtle misalignments around the different types of testing that perhaps we need a bit of a radical simplification to all this stuff now. And, you know, I'm going to blame something. I think it's all because of integration tests. So I want to talk about the murder of integration tests and their replacement with a thing that we barely have a name for yet, because there's no better way to come to a standard by making up a new name. So integration tests are dead. They're history, they're useless, totally useless artifacts from a simpler time. They're a complete contradiction. See, if I were to ask a handful of people in this room, I could probably source a handful of different definitions of what an integration test is. There's the traditional definition, where an integration test is a test covering the interactions between more than one class or function. That's it. Now, there are folks that use them to describe tests that include the integration of your code and external systems like databases that are within your control. And then there's people that use them to describe testing everything except the integration of your code with external systems like databases. So the two opposite definitions. And faced with this fundamental contradiction, we're probably best just setting fire to the term and never using it again. Like, it's garbage, it doesn't mean anything. It's too broad. Sorry, integration tests, we loved you, but you're dead. It's the literally of programming, where recently literally was redefined to also include figuratively as one of its possible definitions. It's dumb. So, at the same time as integration tests having lost their identity, the sentiment of integration tests is more powerful than ever and more popular than ever. Now, as our computers have increased in power and our test frameworks have become more sophisticated, the kind of fast feedback cycles previously reserved for the humble unit test have been expanded to a place where you're using modern tooling and you're capable of running your entire application in memory instantly. Even more interestingly, when you combine the speed at which we can now run our entire apps in memory with the more sophisticated approaches to kind of mocking and stubbing, it's increasingly common to find test suites that can be mostly executed outside in, but with tiny invasive cuts to switch out data storage or network services, and network dependencies with something that can be manipulated from within the test code base. Now, these full stack tests or in-memory tests or integration tests, by some definition, they allow you the liberty to TDD what you want your application, your website, your API to do without really having to worry so much about like traditional low-level integration tests. And over the past 5 or so years, everything has kind of sped up and services have become smaller because of microservices. It's an increasingly popular style of testing. But it's kind of like, it's the testing style that's a little bit of all those other testing styles. So why has it been so difficult to find a name that sticks, right? And it's more about workflow and test isolation than what you're testing, actually. And it's related to the increase in performance of tools over time. But, it's okay. I'd rather we not like lose ourselves trying to coin a catchy name and spend the time actually thinking about the thing, right? And I think the one real defining characteristic of this style of testing is its tests and as much of your application as possible in process. That's what it is. And in process matters because when it's all in process, you can interact with the stubs and you can play around with the small incisions. It's really, really good. So if we're struggling to find a name for this style, what are its characteristics? Now, tests are fast and execute in memory. Like unit tests, the order doesn't matter. The tests shouldn't affect each other. They're not brittle, so you can change all of your implementation in the middle and the test should still pass. They test high-level business functionality and then some low-level detail where required. And they're generally authored in this high-level to low-level, TDD-ish workflow, right? And they should still pass if you provide them with a different test data of the same category or class. Now, just because none of the names feel quite right does not mean people have not tried to name this thing. Obviously, some people seem to have settled on component testing, but it feels a little overloaded to me because, it's easy to mistake it for things like web components or some other kind of components. I feel like component is one of the most overused words in our entire lexicon. Maybe what it really is just the tests for our program. So perhaps, instead we should follow Ian Cooper's lead. I don't know if you've seen Ian's TDD Where It All Went Wrong talk, where he describes the emerging style simply as developer tests. And I kind of like that. It is, after all, what they are. We don't need to lose ourselves trying to articulate the subtle differences between subtle different variants of these things for them to be useful to us. Now, the most important thing to me about this style of testing is that it goes hand in hand with the TDD style workflow, if slightly adjusted. Now, while writing traditional tests, it was common to start writing a test for a class, and then you get some kind of system boundary, and you would introduce a mock object and write tests that verified the behavior of that mock. And then you peel the onion back and you go down a level and you repeat that process until you reach the very, very bottom of the stack. Now, it's a fairly slow and laborious process and has often led to a huge amount of repetition in both test scenarios and the kinds of tests that were left behind. By this movement of tests to being mostly in memory, we can change this process to be better. Now, instead of peeling layers off our software away one by one, we can focus on a test-driven, almost behavior-driven style of testing around the outside of our functionality at a speed previously only available to unit tests. So, what this means, instead of this repeated cycle of red, green, refactor at every level of our code as we start outside in, and then as soon as we'd usually consider reaching for a mock, actually, and testing an abstraction, we should instead break out into a very, very low-level unit test around the piece of functionality that we're struggling with. We make those tests pass around the little pocket of complexity, and then instead of using a DI container or injecting it, just new it up and use it, right? And then the top level test goes green, and then you continue. So you end up with detailed tests around the complex bits of your software and tests around your expectations of what it does. It's beautiful. There's no need to needlessly build layered software. We just call the code. It's cool. And it's a style much more compatible with modern microservices and feature-based organization than dogmatic, onion-layered, n-tiered architectures. Now, this repeated cycle of high-level to low-level testing results in code bases with less compromises made for testing, ironically, and with architectures that are more amenable to change because the tests are all either very high-level, what does this do, or at a very detail-oriented level, here is a pocket of complexity that we need to understand. We're liberated from the repetitive onion peel test code bases that are like treacle and that damage our code's ability to change. And what we're really doing is building code that's able to change easily, and that's the most important metric, really. That's the real deal. Now, in the mid-2000s, when lots of thinking and writing on this topic happened, the London Extreme Tuesday Club popularized the idea of what later became known as mockist testing. That's this same onion peel approach where each layer of software mocks and tests its expectations of the one below it. Now, it was promoted as an alternative to traditional classical TDD. And I think this new wave of developer tests both replaces that style completely and illuminates the negative side effects it's had on all of software. The London School mockist style testing is brittle and doesn't survive and doesn't last and was a mistake. So how do you make tests that don't suck? Don't do that. Thank you. Any questions? Go set fire to clean code.